Good morning, everyone, and welcome to Objective We. Thank you so much, Patrick. I'm incredibly humbled by that intro. And today I'm here to talk about being resilient through endpoint security. So actually using endpoint security to stop a threat midway and make sure you're safe in the process. So unfortunately, the topic of today's talk is needed for several reasons. Adversaries are incredibly capable and persistent on the macOS platform. They're evolving their capabilities and their tactics. So for example, recently Elastic Security Labs caught the DPRK, aka North Korea, passing out candy corn malware. It's kind of fun, but it utilizes something called reflective code loading to circumvent static analysis, which is really scary. Then, of course, my team recently passed out a really deep analysis of Cuckoo, which is a malware that kind of crosses between being an info stealer and spyware. So traditionally, you expect info stealers to land on the endpoint and leave really quick with the crown jewels. But in this case, it decided to stick around and persist as a launch agent. So how do we detect these threats that we've never seen before? So my name is Brandon Dalton. I'm a staff security researcher here at Kanji. Previously, I spent 3 years at Red Canary. I specialize in macOS threat and internals research, as well as security tools development. I'm probably most well known for developing Red Canary Mac Monitor, as well as POSIX atomic test harnesses. So quickly, just to kind of give you guys a little overview of what's going on today. So we're talking about the threats. We're also going to have to talk about how we can get the data out of macOS so we can develop detectors to detect these threats. And then how can we actually use these detectors to shut down the threat midway, hence resiliency. So what is out there? We briefly talked about some pretty advanced capabilities, but kind of what is the survey of the activity that's going on out there? So one aspect that I'm incredibly familiar with is the open scripting architecture. So adversaries will frequently utilize this framework to execute malicious code in a script fashion. So they're not going to have to bring a fat binary with them. They can actually execute code and gain access to native APIs through the use of scripting. So one thing that I want to focus on here is Atomic Stealer. This is something that we'll be talking about throughout this talk. But you can kind of see it goes back since 2017. I mean, at least this was the earliest I was able to find adversaries using examples of malicious OSA abuse in the wild. And you can see back in the day, it was mainly those fat binaries like Trojans, adware. But now we're mostly seeing stealer activity, hence Amos as well. And even taking this a step further, just last month, me and my team were talking about recent Amos samples. I downloaded one from VirusTotal. Turns out XProtect did not have a signature for this. So we were able to, just go ahead and profile this activity. But guys, this kind of goes even further. It's a little bit more scary here. There's supply chain horror stories. So unfortunately, as in the case of Jump Cloud's compromise, North Korean threat actors gained access to their tasking framework. So they injected malicious code in the form of Ruby scripts, which then when their customer endpoints checked in with this service provider, downloaded these Ruby scripts and executed on host, persisting as launchd, and then collecting a whole bunch of nasty information. And something I should also say about this is it was incredibly targeted, limited to 5 customers, less than 10 endpoints, mainly targeting executives. So now let's make sense of what we have, because now that we have an understanding of the threats, as well as kind of like the platform we're targeting, where can we get our data from? So where we can start with this is we have to ask ourselves a few questions. So what does a Mac do fundamentally? We have to break these down into categories that we can consider telemetry. So a Mac runs software. Let's consider this process telemetry. You can also create and modify files. So think about maybe writing your CV or something like that. That's going to be a file modification. Talks over the network. So maybe you're getting a FaceTime call from a friend. That's going to be a network connection. Maybe you're going to plug in a Logitech camera to get a little bit better resolution than your built-in webcam there. That's going to be accessories, as well as security and privacy controls. So think about maybe when you're downloading an application from the internet, your Mac has never seen it before. It's going to show you a gatekeeper prompt. Do you want to run this software? That's going to be largely transparent to you, but that's a security control. This all happens incredibly fast behind the scenes. A really nice desktop user interface Apple calls macOS. It enables you to get your job done as well as communicate with people really fast. So what's the issue here? Well, the issue is we need to know what is the real-time state of your macOS endpoint. And the way that we do this is by attaching almost like a health monitor to your Mac. And this is like an agent. So this is going to collect information and a set of events and send them back to a cloud provider where we can then later go through and analyze these threats for threat hunting purposes. So think of these events as like that process, network connection telemetry, accessory telemetry, anything that we just talked about then. Okay, so now that we have an understanding of, okay, so we have some broken down processes, we have different telemetry types. Now we have to talk about how the system can help us utilize this telemetry to stay safe. And the first thing I'm going to talk about here is user space. So in Mac OS, the desktop environment is known as Aqua. Steve Jobs famously said you can lick it. This is different than the iOS Springboard, and it handles your application services and frameworks. And it talks to the kernel largely through system calls and mock traps, but system calls is what we're going to focus on today a little bit. And then on the right-hand side, you can kind of see how different developers kind of utilize macOS to handle things differently. So Firefox likes to spawn sub-processes to isolate web content. That's just their method of doing it. However, Chrome utilizes a different approach as well. So kernel space. Now, this is the fun part of the talk as well, because X and U is not Unix. This is where macOS kind of gets its two personalities. You have the BSD and the mock side of the kernel. The BSD side of the kernel is what we're going to largely focus on today, because at this level, we can kind of authorize that activity at the system level. So for example, if a process is about to be executed, macOS can step in and actually stop that activity before it occurs, which is really cool. And at this level, like I said, macOS can stop it before it occurs. The kernel always has to be performant, available, and secure. So you really don't want third-party code running here, and that's going to be important for later. Detecting unknown threats. So utilizing macOS's capabilities, as well as our understanding of telemetry, how can we go about detecting these unknown threats? So I'm going to introduce something called behavioral threat detection. This is kind of what I like to focus on. And events are essentially a notification that something has or will happen. And this is what behavioral threat detection kind of revolves around, is this concept of eventing. So different types of events might be like logging into your Mac with Touch ID or saving a PDF. These are all atomic actions that can be resolved in terms of events. However, something down there like sharing your screen, that could be a composite of several different types of events, largely coming from user space. So we wouldn't really be able to authorize that activity. So to kind of pull the curtain back a little bit more and kind of show you guys what we're talking about here, events are prefixed with ES, meaning endpoint security. And these are standard events that are minted by Apple. So it's like a common sheet of music that people can read from and all understand. And you'll notice that I kind of threw a little bit of breadcrumbs in here to kind of get you guys familiar with what we're going to talk about next. And that's notify versus authorization events. So in the first case there, logging in with your Mac with Touch ID, that could be a notify authentication event. But for example, maybe launching an application could be authorization exec. And we're going to talk about this later, so don't worry. And these all come from endpoint security. So like I said, it's prefixed with ES. These are APIs that are offered by Apple to develop user land security agents, which again is really, really important because it maintains the security and integrity of the kernel. You're not going to have third-party code, potentially introducing, memory corruption vulnerabilities into that, as well as performance defects. For example, if you did not authorize system activity within a few milliseconds, that could lead to a negative user experience. And endpoint security resolves around the concept of real-time eventing. And this comes from kernel and user space, like we talked about. At this level, you can authorize and just get a notification of system activity. So if you don't want to authorize and you just want to observe, that's totally a thing you can do. It's also incredibly performant. And this is something I want to call out because in the Windows space, E2W is not a performant system to collect telemetry. And there's a lot of work that EDR developers have to do to go through and make that a performant system. Endpoint security offers a lot of really great APIs to mute at both the event and path level. Lastly, it's only available to trusted entities, so you really don't have to be worried about a malware author, standing up an endpoint security client on your system and kind of collecting telemetry in that way because it is a restricted element. So there's a few different classes of events as well that I would like to discuss, and I kind of gave you guys a little bit of an introduction to that with the notification versus authorization events, red and blue. So the notify events, they largely come from user space. And the authentication events largely come from kernel space, where they can actually be stopped before an activity occurs. And like I said, that's mostly on the BSD side of the kernel versus high-level user space events, which are things like maybe adding a background task, adding a login item, an XPC connection being connected, even X detecting malware. That's all coming from user space. Whereas on the authentication side of it, authorization side of it, we can actually stop system calls midway. So, exec, memory mapping, these things can all be stopped before they occur. The next topic I would like to introduce is event correlation, because this is incredibly important for behavioral threat detection. So everything was initiated by a process. A process is responsible for initiating all this activity. So for example, in Google Chrome, you save a file. Google Chrome is initiating the activity of creating a file. Spotify, you load up a new album. It's connecting to that API. Spotify is initiating the activity of connecting to that web domain. Terminal, you spawn curl. Terminal is responsible for execing a subprocess that will handle downloading something. Now we got to talk about collection. And there's a few different examples here, and it's going to depend on your use case. There's a few that I would love to call out here. So ESLogger is built in by Apple. It will dump telemetry to the command line. Mac Monitor was developed by me, screenshot in the bottom left there. And it kind of enables you to work with endpoint security telemetry in a workbench environment, as well as process file and DNS monitor, which was, of course, created by Patrick Wardle, Objective-C. And you can kind of see a screenshot of that in the middle there. And if you fuse those three together, you have a pretty substantial security product. ESF Playground, of course, developed by the Mitten Mac and Jaron Bradley over there. Hopefully, you guys got to see some of his training yesterday. So building a detector. We have to answer a few questions before we can go ahead and operationalize everything we just talked about. Because I kind of got you guys understanding the threats. We talked a little bit about telemetry. We talked about how we can send this back to a backend to enable threat hunting. So now we have to ask, what data do we have access to? What threats are we going to be looking at? What are the end behaviors of these threats? And after, of course, we're going to have to test it, because there's no real way to just read through research and develop detectors. So our data source, we covered this one extensively. It's endpoint security. Hopefully everyone kind of has a brief idea of that now. The next thing we're going to talk about is our threat. So a case study that I would like to go through with all of you is Amos. So Amos is the atomic macOS stealer. This has been making the rounds quite a bit recently. In the middle there, you can see a screenshot of the malware author actually advertising the capabilities of Amos. So hey, it's going to steal your keychain. It's going to grab some system information. It's going to grab stuff from your documents and your home and your desktop folder. It's also going to grab your macOS password, and it's going to test this to make sure it's actually correct. So that dialog prompt down there, that's actually coming from the Amos malware itself. And you enter your password, and it will keep asking for it until you enter the correct one. So you really don't want that running on your system, right? So now that we have that threat, how can we develop a detector for it? Well, we have to test it. We have to see what the end behaviors are. So let's grab a sample. Let's get a little bit into the weeds. Unfortunately, this isn't going to be something that I'll demo for you guys live, although there will be a little bit of a video at the end where you can see the live malware running. So I'm going to download a sample from VirusTotal, the one that XProtect did not have a signature for, and I'm just going to execute it. It's going to ask for my password. I'm going to go ahead and enter that a few times, and then we're going to take a look at the end behaviors. So I used Mac Monitor to kind of go through the telemetry here, and I color-coded exec events to indicate ad hoc signing. So the first thing I want everyone to kind of identify here is Amos is ad hoc signed. So let's make a note of that. The next thing that we can kind of notice is the sample executed for about 2 minutes, going up this process correlation tree here. It executed, and then it exited 2 minutes later. It also created 3 folders, and those, 3 files, and those are all highly suspicious, like login, keychain, password entered. And if you look at these, they actually do contain the information they're describing. So now let's look at the process groups. So every process belongs to a group, and we can kind of use these groups to identify the behaviors that these malicious activities are going after. So in this case, just taking a look at this one here, we can see it's using OSA script to hide the terminal. That's really funky. You execute something, the terminal immediately disappears, and things just start happening in the background. It's no good. It also grabs hardware information with System Profiler and will display a dialog with OSA script. So let's make a few more notes here. The correlated events, it included the OSA script command line to go ahead and display that dialog or hide the terminal. So we can use this to kind of, identify the malware executing in its early stages. The next thing here is I want to go through this as well. So this is the same process group. I just scrolled up a little bit, and it's searching for installed applications using the metadata find command, which is very similar to Spotlight. And then it's using a combination of xargs and base name to go ahead and kind of just get the name of that application itself. So let's go ahead and make a note of that as well. I mean, like, why is all this activity happening together? Like, we could probably make a heuristic for this, right? So let's note that. Okay, so we know the end behaviors, we have our threat, we know what data we have access to. Let's go ahead and kind of offer something up. So pivoting off of authorization exec events, we can kind of walk through this, okay? So we noted that xargs was a little bit suspicious. We noted that the group leader was ad hoc signed. That is also suspicious. We noticed that in its group leader, it also called into OSA script. But since we're in security research, we know a little bit more than the threat actor potentially here. So in the case where the threat actor no longer wants to use OSA script, what if they want to use the API variation, NSAppleScript or OSAKit? In that case, the process will actually map these components into memory, and we can actually stop it at both points now. And I'll kind of go through that in the demo. All right, that's great. We have a really simple detection heuristic. It sounds good. It might work well in a lab environment. So let's go ahead and test that out. Actually, before we do that, though, I would like to kind of talk about our two options for this, because there really is two different ways you can go about approaching this. Ideally, you would like to use your malware sample that you tested these behaviors against, but that's not always appropriate, especially in a demo environment like this. The next thing you could do is engineer some sort of emulation. And what I mean by this is you're literally writing a piece of software that utilizes these end behaviors that we just talked about. So let's go ahead and take that approach. And what will that look like for us? Well, we kind of noted three different things here: ad hoc signing, xargs, and leveraging OSA. So what can we do? To get ad hoc signing, just compile locally. It's super easy. To call into xargs in the same process group, you could use something like popen. And two variations of AppleScript as well. So you could use the API or the command line variation. And then in the bottom here, you can kind of see what that result of an emulated threat might look like. And we'll have it do some kind of like sentinel value to say, okay, the malware successfully ran, so I'm going to create that danger.txt file. So demo time, and the result will hopefully look like this at the end, where we run our endpoint security client. It matches on this heuristic that we developed, and then it will kill Amos midway through. So let's go ahead and do that. I developed a very simple endpoint security client called Objective Defense specifically for this talk here. And it's loaded up with a heuristic which will detect when Amos is running based off of those end behaviors that we just described. So we run the Amos sample. It executes that AppleScript command line there, and then it dies. So we'll get this notification from endpoint security. Hey, we pivoted off of this exec event, and we detected Amos stealer, and we killed the group leader, ending the activity, hence being resilient with the use of endpoint security. Okay, and next, as a quick treat for you guys, I'm going to show you what running the actual malware looks like. So what did my analysis environment actually look like? I booted up MacMonitor here, and I executed the sample. You can see it hid the terminal there. I'm going to enter my wrong password so you guys can notice that it's actually trying to get my correct password. As soon as it does that, it will write that to disk, and endpoint security will kill it based off of our resilient detector here. Okay, so we just described threats. We described how to build a detector using the data sources we have access to. We described how macOS can interject midway to kind of stop threats. The last thing that I would really like to note here is we have to tune things at scale. This works well in a lab environment, but what's going to happen here when you deploy this across the thousands of customers, you're likely going to see a lot of noise, right? You're going to see things like, hey, Visual Studio Code's doing something funky. You're going to have to tune that out. But eventually, you're going to get to a state where you can develop a heuristic to detect these unknown threats. So thank you guys very much, and thank you to Objective We. And I think I'll be passing it off to Sal now. What is that? Oh yeah, of course, yeah. Be accepting any questions for, yeah.
So endpoint security, amazing,
Yeah.
great presentation, super interesting.
Thanks, Patrick.
Yes. Oh, the box. Can you toss me the?
Oh yeah,
Yes.
I didn't even know.
This is why we wanted to do Q&A, so we get to toss the box around. First, thanks for presentation, super awesome. Are there any events that you would like to see Apple add to endpoint security? And if so, what's the procedure for making that happen?
Oh God, yes. Yeah, so there's actually quite a few that I would like to see added to endpoint security, but it's not even the events themselves. It's actually the enrichment, you know? Like they've minted so many of these types now. We have like 150 or so. And they're really, you know, they're on the surface level, right? They can tell when something's occurring, but really they're not enriched to the level where we can use them for like deep detection, right? And so the way that I've gone about this and the way my team has as well is like giving feedback to Apple through Feedback Assistant and kind of like waiting around for that to happen. You know, they'll kind of come back to us and, you know, say like, hey, you know, you can do this, this, and this. But, you know, we would really like a little bit more participation there to kind of enrich those events a little bit more. One I'll kind of spell out there is XPC Connect. That one is new for last year. It could potentially we could develop really advanced detectors using that event only if it was enriched a little bit more. So, yes, of course.
Sweet. Your heuristic, it made me feel like it should have killed it before it popped the OSA script prompt. So why did it not do that?
Yep. So actually, if we look at the heuristic here, all of these things have to trigger at once. So XArg spawning. So at that point, I was like, all right, I don't want it stealing activity before then. So I'm just going to pivot off of this event. But then it has to have displayed the dialogue. And that's how we're kind of, you know, identifying, hey, this is also malicious because I wouldn't expect something ad hoc signed to be displaying dialogues and using XArgs in this way, if that makes sense.
I guess I'm still a little confused because like it already loaded OSA script. It already executed OSA script. So shouldn't it have already been mapped? Shouldn't it have already have executed?
So yeah, so the difference here is we killed the process by sending a signal. We didn't authorize the activity at the endpoint security level, if that makes sense.
Gotcha. Okay.
Yeah.
That makes sense.
Yep. So it was really a detect then kill.
All right. When you're researching these malware, does Apple's own protection get in the way? How do you get that out of the way?
So honestly, that's kind of why I like emulating certain threats is because I can kind of, you know, make it my own, kind of read through the reports and kind of, you know, develop that end behavior. But yeah, so I mean, XProtect is updated decently often. But like I just kind of showed there with my team, you know, if you kind of get something within a month, there's a pretty decent chance, you know, XProtect won't have a signature for it. But you know, these things are getting better. XProtect is starting to build in behavioral services as well. So that will be more for later as well. Yeah. So yeah, it definitely does get in the way.
Have you seen like legitimate activities that use OSA script and also launch kind of like boxes that ask for users' password like this?
No. So actually, that's a very high fidelity detection opportunity. Dialog displays with OSA script tied to other suspicious behaviors like this, I can't even tell you how many times have led to true positives. It's fascinating, right? But yeah, OSA script is used, you know, very extensively for automating the macOS platform. And you know, internally at Kanji, we use it for a bunch of things as well. But displaying dialogues like this asking for a password, no.
Okay, how fine-tuned is this heuristic for this variant of Atomic Stealer, and is it generalized across other variants?
So one thing I kind of, you know, I want to make it a little bit, yeah, that's a good point. So one thing that I like did to make this a little bit more generic is because the adversary spawned the OSA script command line tool, there's of course that API variation, right? Because I knew that in the future, they're going to read our security research. They're going to know that people detect off of OSA script, right? But they can't get around mapping this into memory, right? As soon as they call into the API, these things are loaded into memory into that process. And, in theory, we could authorize it and just deny that from occurring, and the process would panic and die. But yeah, so really the two things here that I would say that are very tuned to, this sample is kind of XArgs. So if they, chose a different approach there and chose to not use XArgs to get the installed application names, yeah, this would no longer work.
Does the ES framework contain like a session identifier or something that's like more generic than like exec target?
Yep. So actually, the endpoint security messages themselves contain a lot of information, and exec is probably one of the most enriched ones, although to Patrick's point, there could be a lot more in there. And yeah, so it will contain things like session leaders, and we can call into other parts, using like proc info to get these pieces of information if it's not available. So yeah, I mean, endpoint security kind of provides a lot for us here. It's just, depending on how advanced we want these heuristics to be, is how much help we're going to need from Apple later.
Also, if no one else has a question,
Yeah.
I don't want to ask twice. Second question, how does it instantiate a session? Does it use like get SID or create SID, or does it do it itself internally? Like how does it establish what a session is?
How does endpoint security?
Yeah.
Oh, I mean, so endpoint security is not really doing any of that. It's kind of just collecting things as it goes through the kernel. So, you'll see this POSIX exec event go through. It's kind of just recording everything that's going on there. So really, it's just the system that's handling the sessions and the groups.
Gotcha. That makes sense.
Yeah.
So if the process spawned like make a new SID, then would
Yeah,
that...
you would catch that. Yeah,
Gotcha.
absolutely. Yeah. And these are all like really cool ways, to develop behavioral detectors for, right? Like, oh, is a process like creating its own session, right? Like, yeah, totally in the future, these could be malicious behaviors. Yes.
So you said this is a detector, right? Are you
Yep.
guys working on a way to like it actively attack the malware too, or
Oh, yeah. So, I mean, I guess this has been the closest I've come to like attacking the malware is like killing it halfway through. You know what I mean? You can kind of take it a step further by quarantining the threat as well. So, kind of making sure that it can't be executed again. But yeah, I mean, that's kind of like the two different ways that you could take it. It's either authorize it, kill it, or quarantine it.
thank you.
Yeah, of course. Good question.
Anyone?
I have more questions. I love asking questions. Is there any chance that we would expect to see some feature like this in Kanji?
Oh, we are very much thinking along this road. Yes. Yeah. Yep. Yep. We want to make sure that we can detect the most advanced threats.
Sweet.